This is our interim presentation of the analysis and redesign of a staple gun. The staple gun is a handheld, fully mechanical tool where you squeeze the trigger to dispense staples. It's used for construction, upholstery by contractors and teachers, also for DIY projects. The staple gun market, so for the total US stapler market size, there are 3.34 million staplers in the market. Our expected market share for the staple gun is 5%. This leads to a production volume of 167,000 per year. Our primary customers are professional contractors using it for carpeting, upholstery, and professional projects. And our secondary customers are teachers using it for classroom projects and poster boards. Here we also have our exploded views of the CAD model. As you can see on the right, here we have all those parts labeled. So the main task function in our fast diagram is staple staples. We also have the functions place staple, hold staples, and reset assembly. We also have assure dependability, assure convenience, enhance product, and please senses. Also with place staple, we have to guide the staple and detach the staple. For assure dependability, we also have protect inner components. And for assure convenience, we also have ease operation.
So here are two fishbone assembly sequences. The one on the left, we designed really just to optimize for the sub-assemblies that are adjacent to each other in the final staple gun assembly. And the one on the right, we conducted a little industry research to see what are the common practices for staple gun assemblies. We also optimized for allowing for parallel assembly. And so if we move on to our comparison, you can kind of see how this is reflected. Both sequences scored pretty high, but the one on the left fell short, mostly because, again, we really optimized just for having the sub-assemblies next to each other in order. Whereas the one on the right was optimized for allowing for efficiency and assembling in parallel.
So this is our function component mapping matrix, which was created using the final leaves from our fast diagram and used to, we also confirmed that each component of our staple gun was tied to a specific function.
In our bill of materials, majority of the parts are aluminum die-cast or injection molded ABS plastic. All components in the BOM were sourced from CAD, and prices were calculated from online cost estimators like Custom PartNet and Hubs. We assumed manual assembly for each component. We decided to include tooling costs in addition to the material and assembly cost, and material cost is derived from current market rate. Staple guns are a commodity product, which leads to more competition and lower profit margins, and they also don't have complex components, which means ease of manufacturability and market saturation. This explains why the manufacturing cost and market price only have a $12 difference, with the manufacturing cost being $17 and the market price being $29. So looking at our quad chart, we want to redesign the parts with high cost and high functional importance to a DfMA, and hopefully eliminate components with high cost and low functional importance, or redesign to where the costs are significantly lower.
So we use the supporting leaves from our initial fast diagram to determine which functions are the same and different for each customer group. We decided that the major functional differences between contractors and teachers were ease of operation and pleasing senses. The teachers would most likely prefer an easy-to-use staple gun, where the contractors would likely want something more heavy-duty, not necessarily easy to use. From there, we determined two modules that we could easily implement to account for the functional differences between customer groups. These modules were the handle of the staple gun and the load spring.
So for the first module being the handle, in terms of customer group 1 being construction, the current handle is made of aluminum and is more heavy duty. Whereas for customer group 2 being the teachers, our redesign included a cutout to increase the ease of use, as well as changing material to be made of plastic to make the stapler more lightweight. Next, for the module of the load spring, currently the spring is made of steel, and that would align with customer group 1 for construction uses. Our redesign here was to change the material to be made of music wire to require less force to actually use the stapler, where teachers are using it for projects like poster boards and other DIY projects. In terms of how these modules interface with the other components, the handle interfaces with the outer case and the large brackets with a pin going through them, as well as with the hook and spring mechanism to actually move the stapler. And the load spring interfaces with the dropper that it sits inside of and protected by the environment with the top cover.
So these are our product family assembly diagrams. The first top assembly diagrams show, based on our fishbone assemblies, what the assembly line would be like if we just did for our primary customer group, the construction workers, and then our secondary customer group, the teachers. Our last assembly diagram uses the delayed differentiation concept and is a combined assembly diagram for both. And so as you can see, at the end of this assembly diagram, we have our two product variants included as a part of one assembly. Thank you.